So just a little starter here that you can do, so just pause the video for a little second. This should be stuff that you've covered previously, and we'll build upon this and expand a little bit in the information that we're going to cover during the rest of the PowerPoint. So maybe pause for a minute and then I'll chuck the answers on once you've done that. So the question's referring to these chromosomes of this person here. You can see there brown eyes, because it tells us in the top that brown, that's our capital B, that's our dominant characteristic. Even though they've got the brown and the blue allele, they're going to have brown eyes. Next up, it asks you for their genotype though. Remember, your genotype, that would be both copies of the allele that they carry, the set of genetic information for this person for that gene would be big B, small b. The second part of starter just says, where did the person get these two chromosomes from? So that at the top, both the chromosomes that they are, this one and this one, where did they get those from? Hopefully you're able to say they get one from either one of their parents. So they get this one from the male parent and that one from the female parent. And then lastly, it just says what would be the genotype of a homozygous recessive individual. So just thinking about what those words means again, remember, homozygous would mean that they have two copies of the same allele, and if they're recessive, that's going to be depicted by a small letter. So that would be the person that they're referring to there would be little b, little b. So we're going to build upon this information in a wee second, and we're going to look at interpreting family trees. I'm going to talk through an example of how I would go about constructing a family tree, talk you through then how I would work out the genotypes of different individuals in a family tree, and then I'm going to get you to do a little example and you can check the answers in a wee second. So first off, I'm just going to use this information that's on the screen just now in order to create a family tree. After that, what I'm going to do is I'm going to write the genotype of each of the individual people in that family tree. The very first thing that I need to do in this process is I need to make a key. So my key, I'm going to have males and I'm going to have females, and I'm going to have one colour that's going to be representing brown eyes and one colour that's representing blue eyes. So just to talk you through what that means, my circles are going to be female, so I'm going to have a circle that's black, that's going to be my individuals that have, my females that have brown eyes, and I'm going to have a circle that's white, that's going to be my females that have blue eyes. Similarly, I need the similar symbol for men. So men, they're just going to be a square, and if you're male with brown eyes, you're going to be a black square. If you're male but you've got blue eyes, you're going to be a white square. So that's just showing what our key is up the side here. So I just need to work through this information that I have here and produce a family tree. And I'll talk you through how you do that. So you start at the top with the father here. The father, he's a male, he's got brown eyes, so I'm going to draw a black square. The mother in this situation, she's going to be a female, she's going to have blue eyes, so she's going to be a white circle. So I have these two individuals. To show that they went on and had kids, what I do is I draw a line to show that these two are the parents, and then to show their offspring, their children, I draw another line down. You'll see here they've had 3 kids, Jim, Kate and Derek. So Jim, just the first one, he is a male that's going to have blue eyes. So what I do is I draw a line down from here and I put a white square just to show that they've had a child, and that child is a male with blue eyes. And then I just do the exact same for the other 2. Kate, their daughter, so she's a female, she's got brown eyes as you can see in the table, so she's going to be a black circle. And Derek, their other son, he is a male, he's got brown eyes, so he's going to be a black square. What you can also see is that Jim, this individual down here, he's went on to have his own children with Jane. Jane is a female and she has blue eyes. So we do a similar thing as to what we did at the top. We put Jane in, our female with blue eyes. We draw a line between her and Jim showing that they've had kids. And then we just show their child. So Patrick, their son, has blue eyes. So a blue-eyed male, we use a white square. So that's the first part of this done. For the next bit of information, we're going to talk about which one of these characteristics is dominant and which one's recessive. So as you can see here, brown's dominant and blue is recessive, because brown's depicted by our big B, whereas blue is our small b. what we are then going to do is we're going to work out the genotypes of each of these individuals. And this is really important to remember that one chromosome comes from each of the parents. As we discussed in the starter, that's going to be key to working out the genotypes of each of these individuals in a wee moment. If I was faced with a situation like this, the very first thing I would do is I would fill in all my individuals who display the recessive phenotype. The reason that I do that is because in order to display the recessive phenotype, you're going to need 2 copies of the recessive allele. You're going to need to be homozygous recessive. So all these white ones, we can fill all them in straight away. They're going to be little b, little b, little b, little b, little b, little b, and little b, little b. As I've said, that's because they're actually displaying the recessive phenotype. That means that they can only have 2 copies of the recessive allele. If they had any copies of the dominant allele, they would be displaying that characteristic. The next thing that I do is I would go through and beside all of these individuals here, these 3 individuals who display the dominant phenotype, I'm just going to put one big B. Okay, the reason I do that is I know that they definitely have one of the big B's because they're displaying that dominant phenotype. I need to work out whether they have, if their genotype is big B, or whether it's big B, little b. The individual I'm going to start with is this person up in the corner, the father. Okay, the key to us working out what his genotype is Jim, his son that's had blue eyes. Okay, Jim, if you remember, we spoke about in the starter, you get half your genetic information from your mum and half your genetic information from your dad. So Jim is little b, little b. So he's got one of these little b's from his mum. We know that for sure because that's the only thing she could pass him on. He, however, has another little b. So the only other place that he can get that little b is from his dad. So this person up here, their genotype needs to be big B, little b. And then it's just the same sort of thought process that we go through here below. We've got this individual here, we've got Kate. She has one big B. She definitely got this big B from her dad because that's the only thing that he could pass her along. But she's going to have to get half her genetic information from her mum. If we look at her mum up here, the only information that her mum has, the only forms of these alleles, is a little b. So that's the only thing she could pass on. For that reason, Kate is going to be big B, little b. And it's a similar situation with Derek here. Again, he got the big B from his dad. His mum's going to give him half his genetic information. So what she's going to have given him is a little b as well, because that's the only thing she could pass along. So here's just another example. What I'd like you to do is to use this information in this table to firstly construct a family tree. I'd recommend you pause the video and then work through this and then check your answers after you've done it. What I'll do is I'll put up the family tree first. After that, I'll put up the genotypes of the individuals and talk you through how those will be worked out. And there will be one person in this family tree who you can't work out their genotype for certain, and I'll discuss why that is in a little second. And then I'd just like you to do this last bit here, which is put in the correct symbols, the P, your F1 and F2, beside the appropriate, in the appropriate place in your family tree once you've done that. So it's using this information here to construct a family tree, then working out their genotypes, and then identifying what individual you can't work out for certain and thinking about why that can't be, and then doing this little bit here with the different symbols. So if you want to pause this, have a go at that, and then start again after you've had a wee go at that. So the very first thing, your family tree, this is how it should look after you've had a go at constructing that. Okay. It wouldn't be very common that you'd be asked to actually construct a family tree, but what you might have to do is this next stage is work out the genotypes of different individuals in this. Okay. Again, the very first step you should go through is just put in the genotypes of all the individuals that are displaying the recessive characteristic, because we know again that they have 2 copies of the recessive allele. Okay, because they're going to have to be homozygous recessive. So all the white individuals in this are going to have to be 2 little t's. Okay, so little t here, and here, and here, and here. Then again, my next thing I'm going to do is I'm going to put a big T beside all the ones who display the dominant phenotype. Okay, because we know they have to have at least 1 copy of the big T. So I'm going to have a big T here, I'm going to have a big T here, a big one here, a big one here, and a big one here. Then I'm going to go and try and work out the genotypes of these individuals. Okay, so seeing what is the other allele that they may have. I'm going to start with this person right at the top, with our father at the top, and it's a similar situation to the last example. To work out his genotype, I need to look at his kids. So if I look at his children here, I can see that when he's went on to have kids, two of his children have the recessive phenotype. In order for them to have the recessive phenotype, they've had to get half their genetic information from their mum and half their genetic information from their dad. Okay, so we know that the mother's definitely given them a little t. The only other place they can get their other little t is from their dad. So this individual at the top, he's going to have to be big T, little t. Next up, I'm going to look at these children here, and again it's a similar situation to what you had last time. You're going to get half the genetic information from the mum and half from the dad. So this individual here, we know that they've definitely got this big T from their dad, because that's the only person that could pass that along to them. Okay, they're going to have to get the other half of the genetic information from their mum, and the only thing that she can pass along to this child is a little t. So this person again is going to be big T, little t. It's a similar situation with their other child who's able to roll their tongue. Although they've got the dominant allele that they definitely got from their father, from the mum, the only thing that she could give them is the recessive form of the allele. So she's going to give them the little t. So their genotype would be big T, little t. Next up, we've got these two individuals. So we've got Andrew and we've got Susan. Okay, they've went on to have two children. One of their children, importantly, can't roll their tongue. They display the recessive phenotype. So they got one of the little t's from Susan, we know that for sure. The other one, the only place they could get that is from Andrew, okay, from their dad. So he's is also going to be big T, little t. And then our final individual down here in the corner, who we need to work out, they're a little bit more tricky, okay? They could get the big T from Andrew. Okay, let's just say that they get that definitely from Andrew. If we look at what Susan could potentially give them, Susan could give them one of her big T's. She could give her the big T that she has to make them big T, big T. But she could also have given them, if they got the big T from Andrew, Susan could have also given them a little t, and we wouldn't know that because if they were heterozygous and had one dominant and one recessive allele, they're still going to display the dominant phenotype. So this individual down here in the corner, Michael, they could be either big T, or importantly, they could be big T, little t. Okay, and we can't say for sure for that individual. And then just with the symbols next that you have to fill in next, just to put where the P, the F1, the F2 is. So your P is going to go at the top beside these parents. F1 would be this next generation down here. And then F2 would be these bottom individuals here. So hopefully now you'll be able to work out the genotypes of individuals from looking at the family tree and the different phenotypes of their relatives. If you need some more practice, I'm going to stick one more example of this on the next slide and that you can have a go at as well. So this is the next slide. Again, just pause it and I'll quickly talk through how you'd work out the genotypes of each of the individuals. And then just a little bit, two other questions. What symbols would you put in these other boxes, X, Y, and Z? And then what numbers show the offspring of individuals 1 and 2? Just another wee question. So maybe pause this, have a little go at it, and then check your answers in a wee second. So again, the first thing that you do is just fill in all the recessive individuals. So here we've got free earlobes as dominant, attached earlobes as recessive, and our white again is going to be our recessive characteristic. That's not always the case. Sometimes it could be black that's the recessive and white's the dominant. That's just what I've had in these examples. So it will tell you in the question, it will tell you which one's dominant and which one's recessive. So just make sure that you read the question and you look at the key that's provided. But anyway, if we're filling in our recessive individuals, so 2, 4, and 7, they are going to be little a, little a, little a, little a, and little a, little a. And then, Again, next step, you just add in the dominant allele for all the ones that are displaying the dominant phenotype, because you know they're going to have at least one copy. So 1, 3, 5, and 6, they're all going to have at least one big A. Then again, we'll start with 1, just working this person out. We know for a fact that they've had a child, and their child is homozygous recessive, so they've got 2 little a's. We know that they got one of them from their mother. The only place you could get the other little a would be from their father. So this number 1, they're going to have to be big A, little a. And then again, looking at the children here, the siblings of individual 4, 5, and 6, they are going to be big A's, little a's as well, because they're going to get the big A from their dad, and then their mum, she's going to have to give them the little a. So they would be big A, little a, and 6 would be the same. And then just to work out individual 3, you just need to look at the child that they've had with individual 4. So if we look at 7 here, there are 2 little a's. Again, they're going to get one of those little a's from their mother. The only place you can get the other one is from their father. So the number 3, sorry, they got one from their father. The only place you can get the other one's from their mother. So this number 3, the mum in this situation, is going to be big A, little a. And then again, just thinking what symbols go in these boxes. In X, it would be P, and Y, it would be F1, and Z, it would be F2. And then just the final question here, what numbers are going to show the offsprings of individuals 1 and 2? So these 2 people here, they went on to have children. The numbers that show their kids are 4, 5, and 6, not 3. Okay, although 3 is in the same line, that's an individual that 4 has then went on to have children with, but they aren't the offspring of 1 and 2.